Hello everyone, in this video we are going to solve an interesting logarithm equation over here. Now as you can see, we have log base 2a plus log base 3a being equal to 1, and obviously we are supposed to find what the value of a is. So now if we look at this logarithm equation, now let's look at how we can solve this. Now you can see that from the equation we have the log of a base 2 plus the log of a base 3 being equal to 1. So in this case, you realize that we can basically use log properties in solving some of these things. So we have a log property. So a log property, let's say the log of x and y we know is equal to, so let me put it property equal to that. So it's just basically the log of s plus the log of y. So if you have two variables multiplying in logarithm, then their respective answer should just be the log of what the variable, or the sum of the log of one variable and the other variable. In the same way, if you have log of x over y here, where they are divided, then you should have log of x minus the log of y in this case. Now if you look at the equation over here, then you could see that the log has different bases. So what I'm going to do from here is that I'm going to send this base 3 to the other side, so that we have log of log base 2a being equal to 1 minus the log of 3 base log of a base 3. So in this case, you realize that what we can do, if we look at the right hand side of the logarithm equation, you could say that since it has log of base 3, we could write 1 here in terms of log base 3, because one property, so another property, so let me call it b2, another property of log is that if you have 1, then it's the same as the log of 3 base 3. So that is basically equal to 1. So basically, let me just replace that. So let me substitute that into that. So we have 3 here, and then we have been minus the log of a base 3. Now we have a very nice equation which we can then go ahead to write the right hand side here, as since they have the same basis, we can just write log base 3 outside, and then we have 3. Now remember, from this property over here, we said that if you have from this property, the second property that we wrote over here, the log of x over y is just the log of x minus the log of y. So in this case, we have the same basis, we have 3 minus a. So in this case, writing it in reciprocal form, we have just 3 here being divided by a in this case. So we have a very nice equation over here. Now from here, we can then go ahead to set both sides to a certain variable. So let's say, so let's set, let's say a variable b being equal to the log base 3a, also being equal to the log base 3, and then we have over that. Now why are we setting a variable to that? We are going to see the reason why we are setting a variable to that, to each of the variables. So we can say let b equal to log a base 3, and also another equation where we have the log of base 3, we have 3 over a. Now since we have this equation, then we can then go ahead and then further simplifying this. You can see that from one property to another property, so let's call it property 3. If you have a variable a over here, and then you have, let's say, log base 10, and then you have b over here. Now another way to solve this is the 10 here goes to raise that, in order for you to get rid of the log. So in this case, for us to get rid of the log, the 10 here goes to raise the a, becomes 10 to the power a being equal to, then we have b in this case. So basically we are going to use this property here in solving that. So this 3 here goes to raise that, we have 3 to the power b being equal to a. Then in this case also, we have 3 to the power b being equal to we have 3 over a. I'm quickly going to call this one equation 1, and then equation 2. So now this place was basically log base 2, so it becomes log base 2 log base 2, so it becomes 2 to the power b. So we have equation 1 and then equation 2. So what I'm going to do next is that we can actually solve this system of equation either using substitution method or the elimination method. Whatever method we use, we should get the same answer. So now that we have a system equation, we can only get rid of one of the variable, and this variable can either be a or b, but then we can get rid of a. So you can see that from here we can just basically get rid of a just by multiplying equation 1 and equation 2, because when they multiply, this goes away. So let's say equation 1 here, equation 1 times equation 2. So we have equation 1 to be 2b being equal to a, and then 3 exponent b being equal to 3 over a. Now multiplying them, you realize that a will get rid of that, and therefore we have 2 to the power 3, and now we have 3 to the power b being equal to, now what is left here is just basically 3. Now in this case we have 3 multiplied by 2. Now if you look at the exponent, they have the same exponent, so basically we can write this whole thing as just 2 multiplied by 3 here, 2 multiplied by 3, and then it becomes to the power b being equal to 3. So basically 3 times 2 is just 6 to the power b being equal to 3 in this case. Now we have 6 to the power b being equal to 3. And what we can do now is that we can apply log on both sides, but then we can apply log on both sides with a base of 6, to make the work very easier. So for us to find b, we have to apply log on both sides with to the base of 6. So I'm going to apply log base 6b here being equal to the log of 3 base 6 in this case. So because the reason why we are applying 6, the log of base 6 to both sides, is that you can see from here that we said one property of logarithm is that if the same number here is the same as what is here, then which means that the whole thing goes to 1 in this case, right? But then before we can do that, we just have to send this in front here. So we have b, the log of 6 base 6 being equal to the log of that base 6 3. So in this case we can then continue from there, and then we can, so from here we have b. Remember, this whole thing goes to 1 being equal to the log of 3 base 6, and therefore from here we can say b is basically equal to the log of 3 base 6 in this case. So from here what we can do is that since we have b equal to the log 3 base 6, then we said that we should let, remember we said that we should let b equal to the log of a base 2 in this case. So what we are going to do is just substitute that into it. So what is b? B is just the log of 3 base 6 being equal to the log of a base 2. So in this case, for us to find a, we are going to use still the property of log. So what will happen is that the base here goes to raise the whole of this equation on the left hand side. So we have 2 to the power the log 3 base 6 in this case being equal to a. So therefore we can therefore go ahead and then conclude that a is equal to 2 the log of a base of 6. So thank you very much for watching this video, and I'll see you in the next section.